All right, 10-2, day 3. I see I forgot to put the formula on my note card yesterday, or the last time I did these. So, let's do that first. I'm going to take out the note card. I'm going to go regular. And this is our last area formula, so you could use both of these sections if you needed to. So this is for a regular polygon. I think I want to put the, I'll go here, I'll use a little more of the space here. So the important information, that's the radius. This is the apothem. We have the radius over here. The big angle in here is 360 divided by the number of sides. And our area formula is 1/2 apothem times perimeter. Okay, so I'm just going to do a couple of examples. We'll do some more trig, just to practice this again. Hopefully it gets easier on this second day. So this will be 10-2, day 3. Oh, get on centered here. 10-2, day 3. So just a quick couple of examples. Find the area of a regular nonagon. And this time we have a radius of 5. So just like the one we did yesterday, it's just more practice together. Hopefully this gets easier for you. Again, I like to draw the bottom part of just a generic polygon. And what I've got is a radius which goes from the center to a vertex. That's 5. Our goal is to get the apothem. And we got to figure out the perimeter, which means if I knew this distance from the midpoint over, I can double it to get the side length and times by how many sides. So, before we get started, I guess I can do a solid there, it's 5. Let's find the angle inside of our triangle. And again, I need to know how many triangles I would have here. Nonagon, if you remember, 9 sides, 9 triangles. So we'll take 360, divide by 9, I believe that's 40. So the whole angle's 40. The apothem divides it in half, so we get 2 20s. There's a 20 on this side and a 20 on this side. So don't forget to cut that in half, because you're working with the right triangle and not the isosceles triangle when you set up SOHCAHTOA. Always with the right triangle. So we'll stand at the 20. We've got opposite and hypotenuse. That's our sine trig function. So we will set up a sine of 20 degrees equals opposite on top of hypotenuse, x over 5. So 1 gets multiplied by the x. 5 is going to get multiplied by the sine of 20. That'd be 1.71. And if I look, why did I find that again? Oh yeah, I was trying to get the perimeter. So I'm going to times that by 2 to get me a side length. Then I'm going to times by 9 to get me a perimeter. So doubling it, timesing by 9, perimeter of 30.78. half of what I need. Now I need the apothem. So I go back, I'm going to do some more trig. We've got adjacent over hypotenuse this time. That is the ka. So cosine. Adjacent on top of hypotenuse. Cross products. Times cosine 20, 4.70 when I round. And now we are ready for our good old area equals 1/2 AP. 1/2, the apothem is 4.7 times perimeter of 30.78. So 0.5 times 4.7 times 30.78. 72.33. I guess I wanted to show you how this would come out the same if you just found the area of this isosceles triangle and multiplied by how many you have. So we've got the area of the triangle, and then we're going to multiply by 9. Remember, a triangle is base times height divided by 2. And our base, I didn't write that number down, but it's this 1.71 times 2. So let me, 1.71 times 2. 1/2 base times height times 9. Base is 3.42. The height of the triangle is that apothem value. That apothem value is 4.7. And then we're going to times by 9. So if we do it that way, 0.5 times 3.42 times 4.7 times 9. There it is, exactly what we had before. The reason it works is we have our side length times 9. That's just our perimeter combined together here. We do all the same stuff, so whatever your brain wants to wrap around, you could do it this way also. Okay, one more practice together. Number 2. Let's see. Oh, nice one. A circle is inscribed in a regular hexagon. This came off of the SAT. So we've got a regular hexagon. And then we've got a circle inscribed. Inscribed means it's just going to touch the midpoint of each one of these sides. Now, perfect circle. Okay. So, the radius of the circle is 8 centimeters. Can you find the area of the hexagon? Okay, so let's see. If I know the radius of the circle is 8, that means if I draw to any point on the circle, that's going to be 8. What's the most advantageous radius for me to draw in? Probably the one that goes to the midpoint of the side. So that distance is 8, but for the hexagon, we would call that the apothem. So we have the apothem value given to us by being given the radius of the circle. What I need to figure out is now the perimeter, which has to do with the side length. So we're going to go back, draw our triangle in. Our goal is to get this piece here, which we can always get with trig, because we will be able to get the angle up here. So, I didn't draw that very good, but the big angle would be 360, you know, the isosceles, right, divided by 6, because hexagon has 6. So that would be a 60-degree angle. This apothem here is cutting it into 2 30s, so I've got a 30-degree angle. Now, I've got a 30. At this point, I could use the 30, 60, 90, or I can use trig. Doesn't really matter. I'm going to go trig, I guess. So, if I go with opposite and adjacent, that's going to be tangent. That's TOA. So the tan of 30, opposite is the x, adjacent is the 8. That'll give us x times 1 is x. 8 times the tan of 30. If I start with the tan of 30, I've just got to remember to close that parenthesis. Times by 8, 4.62. That's only half the side length, so I will times that by 2 to get the full side length. Times that by 6 to get the perimeter. Times 2 times 6. Now we're ready for hexagon. Area of the hexagon is 1/2 times the apothem, which was the 8, times the perimeter, which was 55.43. So 0.5 times 8 times 55.43, 221.72. Okay. Would I have gotten the same thing if I had used the 30, 60, 90? Well, let's do a quick check, and then we'll be done. We've got our 30 here, short leg, hypotenuse, long leg. So, the long leg is multiplied by the square root of 3. To go backwards, we would have had to divide by square root of 3. So this value of x that I found over here should be equal to 8 divided by the square root of 3. Let's check. 8 divided by the square root of 3. Oh, look at that. Good old trig and the 30, 60, 90 work for us. Okay, I'm going to give you some more to practice with the hexagon. Hopefully they're a little easier today. And that is all.